All right, so your I can statement for today is use the law of signs to solve problems. Your vocabulary, wouldn't you know it, law of signs. We are going to do page 195 right now. All right, so this says consider the 30, 60, 90 degree triangle below. All right, calculate the values of the ratios sine A over BC and sine C over AB. How are the ratios related? And then do you think the ratios would have the same relationship in any 30, 60, 90 right triangle? Explain your answer. I'm going to give you a minute to kind of feel this out, okay? It's kind of important stuff. But the one thing I am going to write is the habits of mind. I'm going to write that kind of in the corner over here. I want you to add that to the habits of mind at the bottom of that page, okay? Because this will explain the general pattern with the relationships. So okay, so that'll make a little bit more sense once we get to it. Okay, but I'm just putting it up there so you guys can have some time to write it. And while I'm at it, who missed the quiz that needs to make it up? I'm sorry, guys. I accidentally left the quizzes here last night, so they're not graded. It's gonna happen over the weekend. So Monday you will have your stuff. Mrs. Smith was not thinking clearly yesterday. Sorry. On the plus side, though, it's a pretty easy grade. So, unlike those tests. Oh my god, those tests. The worst. Oh my god. I would have rather graded 2 proofs than those last tests. Those were horrible. Horrible to grade. Something I should make you guys aware of. Do you guys remember first semester when we took that I want to say it was like the first or second test, and there were those extra problems added on? That's happening for this test coming up because we went through the test and we found out the ambiguous case is not there, and that's kind of necessary. So we need to add in an ambiguous case problem. So those I have to figure that into your total score. Okay, again, like we did before. Okay, so don't freak out if it takes me just a little bit to get that stuff in. Okay. How many ambiguous case problems? I don't know. Hopefully just one. But we'll see. I gotta talk to the other teacher. All right, let's talk about letter A. Calculate the values of the ratio sine A over BC and sine C over AB. How are the values of the ratios related? Who can tell me? I am extremely over caffeinated right now, so my apologies if I'm slap happy. But you guys ever see Talladega Nights? No, you should watch it. There's a kid that screams, "Come at me, man! I'm all hopped up on Mountain Dew." That's how I feel right now. So I'll have to find that clip for you guys. It's a funny movie. It's so funny. Anyway, who's got it? What's going on with sine A over BC and sine C over AB? Emma?
Sine A over BC is 0.3 and sine C over AB is 0.1.
What'd you get for the first one?
0.3.
Did you put parentheses around the 5 and 3?
No.
Try in your calculator again. So we're definitely going to have this. Sine of 60 over 5 square root 3. In your calculator, you do have to put parentheses around that. It would help. And then we're going to have the sine of 30 over 5. Now what are we noticing? They're both 0.1, yeah. They're both equal 0.1. So that's why I want to make sure, because I think what it did was it did sine 60 divided by 5 and then multiplied the whole thing by root 3.
Oh, okay.
Yeah, you guys are going to learn today that the calculator, you have to be careful with fractions, like so careful. Okay. If you have that fraction, that math print thing in your calculator, you're going to be fine. You can just do the math print, numerator, denominator, and you're set. But if you don't, parentheses are going to be huge. Okay. All right. So here is the situation for letter B. It says, do you think the ratios would have the same relationship in any 30, 60, 90 triangle? That's a big yeppers. Okay. They will always be equal. Okay. And that's because those proportions end up being the same. Okay. Make sure you still add in this habits of mind, because it does say what general pattern or relationship seems to occur in a triangle between each angle and its opposite side. The ratio of the sine of the angle and the length of the side opposite is the same. That is the big key here. Okay. That is what they wanted you to find. That is the turkey at Thanksgiving dinner. Okay. We are skipping example 1. And now I'm going to bring up the rule for the law of sines, but you don't have to write it down because you have your foldable, right? But you can open your foldable to take a peek and follow along if you want to add anything. Is anybody still writing this before I erase? Sweet. Okay, so the law of sines. For any triangle ABC with side lengths A, B, and C, opposite angles A, B, and C, respectively, the law of sine relates the sine of each angle to the length of the opposite side. So here's the deal. You guys notice the capitals? That's nothing different. It's still a point in space. We always represent that with a capital letter, but opposite it is always this little letter. Okay? So we have big A, then we have baby A. Big C, baby C. Big B, baby B. Okay? And that is actually very important to note. And they are directly across from the angles in question. Okay? One thing I always like to do is I like to draw little arrows. That kind of helps show me what goes with what. And it might help you. Who knows? Okay? Questions before we move on? Okay. So here's what's happening. It says for triangle XYZ, what is YZ to the nearest tenth? Here is a pro tip that you're going to want to write down probably in the blue part. Okay? Always use what is given. Not what is calculated. Sorry, I can't like fit. That's an ED on the end, guys. Sorry about that. I promise I know how to spell calculated. Here's the deal. Your answers are most likely going to be approximate answers. I don't care how nice they come out. Okay? Therefore, if you need to solve for two sides, it is always best to always use what is absolutely given to you. Okay? I'm not saying there won't be a situation where you might not use another side, use it, but 99% of the time you should use always what is given. Okay? In this case, what's given to us, and I'm going to highlight it in purple, is that we have angle Z and little z. So whenever I'm looking to find the sides, I should use the z's in my law of sines. So this is going to be set up the following way. The sine of z over baby z equals, now they want us to find yz right here. Okay, so I'm going to have the sine of x over little x. So there's little x. Now when I substitute this in, this will be the sine of 77 degrees over 7 equals the sine of 51 degrees over x. So we know what we're solving for. I'm going to cross multiply because I know they don't show that here, so I'm just doing the whole thing. So this will be x times the sine of 77 degrees equals 7 times the sine of 51 degrees. And then I divide both sides by the sine of 77 degrees. So this leaves me with, in the end, x equals 7 times the sine of 51 degrees over the sine of 77 degrees. Now, that's your exact answer. We talked about that before, right? That's the exact answer. They're going to ask you, hey, round to the nearest tenth or whatever. And that's when you know you need an approximate answer. Here is how you put it in your calculator. You guys see this right here? OMG, I cannot stress enough. Do you guys notice how the whole numerator is in its own little set of parentheses? You need to do that, okay? So it's going to look like this. I'm going to put a parenthesis, 7 times sine, and then obviously like the trig thing has its own little thing, right? And then I'm going to close it the second time. You should have 2 parentheses at the end and then hit division sine of 77. Try that in your calculator right now. Yeah, Shane.
If you like the thing that you can put a fraction, you need the parenthesis over the whole.
No, you can just do that numerator over the denominator and you'll know.
Okay.
But not everybody has that, so that's why I'm showing it this way. I'll even admit some of my calculators don't have that, so. Make sure you get about 5.6. If you didn't, we need to talk. How we doing? Show hands, who got about 5.6? Who did not? We good? Big Nut, you good? I didn't see your hand go up. Okay. All right. If anything changes, please let me know. Okay? So here's some common errors. Be careful to correctly write the ratio of the sine of an angle and its opposite side length. It may be helpful to draw an arrow from each angle that points to its opposite side, just like I did. Okay? I've been doing this for years. I still do that just to keep things clear. Okay? For your calculator, make sure you use parentheses around the numerator and denominator. If you have the math print where it gives you the fraction, you don't need to worry about this part. But I know not all of you do. Okay? All right, let's move on to the second problem. Now, the second problem is actually going to reuse this triangle, so you're going to have to copy that into your book. So why don't you copy that real quick? Because what they want you to do is they want you to solve for xz. In this case, that's little y. And I purposely did not delete this yet because I want you to remember, always use what is given, not what is calculated. What is given here is the z's, so you should use that in your next ratio. Okay? But what are you going to have to do first? Because you're missing something here for the y's. Emma?
The angle measure, so we're gonna have to
How do we get that angle measure?
subtract those 2 angles by 180.
Yeah, very good. So remember, this is 180 minus 51 minus 77. I want you guys to solve for the rest right now. Go ahead. I'm going to just erase this stuff right here. Oh, FYI, definitely bring your, okay, make sure you bring your companion next week. We're definitely using it Tuesday again. Just a recap for you guys. If you didn't have your companion today, Bring it next week too. You're going to need it. Maybe not Monday, but definitely Tuesday. Okay. Who is still working on this? You are, okay. You got it? Okay. You know what? What's the answer? 5.7. Very good. Does anybody need to see this? You do? Okay. All right. So again, remember, we are going to use the opposite z right here. Okay. So I'm going to have the sine of z, which is the sine of 77 degrees, over the side, which is 7, equals. All right. Now we're going to have the sine of y going to little y. But what was that angle measure?
52.
52 degrees. So it'll be the sine of 52 over y in this case. I will cross multiply. This leaves me with y times the sine of 77 degrees equals 7 times the sine of 52 degrees. I will divide both sides by the sine of 77. And this now leaves me with y equals 7 times the sine of 52 degrees all over the sine of 77, which is about 5.7 from your calculator. Does that help? Are there any questions? All right, let's move on to example 3. Okay, so in this case, now they're saying, hey, what happens if you're given two sides and an angle, right? We need to find that other side. And we're going to use that. Remember how when we were doing SOHCAHTOA, we use the inverses to find the angles and we use the ratios themselves to find sides? It's the same thing here, okay? We're going to have to use that inverse. So in this case, if I look, I have angle T going to little t. So here I'm going to have the sine of 74. Oops, 74. Sorry about that. Over 12.3. I'm setting that equal to, now I have this side and this is the angle that corresponds with this. So this will be the sine of angle S over 12.7. Now it's going to be real tempting here to just automatically do the sine inverse, right? Don't do it till the end. Okay? Please don't do it till the end. It'll make your life a lot easier. Trust me on that one. You guys are going to know you're not going to be able to calculate the sine of S. You know what I mean? All right. So I'm going to cross multiply. I did not mean to do that, but so this will be 12.7 times the sine of 74 degrees equals 12.3 times the sine of s. I will then divide both sides by 12.3 because my goal is to get the sine of s by itself. This leaves me with the sine of s equals 12.7 times the sine of 74 over 12.3. Now, this is going to sound strange, but you got options here. You do. You can do this. A little complicated, but not bad. I'm trying to get this doc camera. I don't think I have the software. So I have this doc camera and I can't do anything with it. Anyway, you can do this. You could do the sine inverse. So this will be the measure of angle S equals the sine inverse parentheses. So there's one parentheses for the sine inverse. And then another parentheses, 12.7 sine of 74, close, close, divided by 12.3, and then close with another parenthesis. Or put this in your calculator, get that decimal equivalent, and then you can click the sine inverse and then hit your second button and then hit the negative button. Above that negative button, it should say something like ANS, yes? What it will do is it will take the answer, all those decimal places that it has, and bring it in. So you don't have to worry about typing all of this in. Please pick a method and make sure you get about what? 83 degrees. Here, I have this for you. Yes. Because in this case the sine of s is acting like our variable. Think of it as like an x. Okay. We're trying to get that angle s by itself, and the only way we could do that is if we get the sine s by itself. Yes, Tony. You want all of it in? Okay. Here's how it's going to look. So these are the steps. You're going to hit, obviously, second sine, right? So that gives you the sine inverse. After that, you should have a parenthesis there, though, right? They give you the first one. Put in another parenthesis, okay? Then you're going to type in the 12.7 times the sine, parenthesis, 74. You close your parenthesis once for the sine part. Close the parenthesis again for the numerator. Then hit divide. Type in 12.3. And then close for that third parenthesis so that this way it's covering the sine inverse. Okay. A little more complicated. Not bad, just a little more complicated. And you might have math print on yours where you can just put in a fraction and then just type it all in. I don't know if it's activated though. We'll have to check that out. Everybody with me? We are on page 197. Did everyone get 83 degrees? Okay. After that, in order to find the other angle, you just subtract. Okay? I want you guys to try example 3 on your own. Try it. I'll leave this up. I know it's kind of messy, but I'll leave it up just so you can look at it. Okay, if you need to. So what is the measure of angle N and what is the measure of angle O given these two? Find the angle. Sorry, guys. Did not mean to do that. Show of hands who's still working on this. And a no. All right, let's see. Who's got N? What'd you get?
28.
28. About 28 degrees, yeah. Who needs to see it? Okay. So looking at this, okay, so here is my M. So I'm doing sine M, which is sine of 70 over 4, equals, here's N, and I have that side right there. So this will be the sine of N over 2. I am going to cross multiply. This will leave me with 2 sine of 70 equals 4 sine of N. I am going to divide both sides by 4, leaving me with the sine of N equals 2 times the sine of 70 over 4. From here, it's inverse. I'm doing, now the measure of angle N will equal the sine inverse of 2 times the sine of 70 degrees over 4, close your parentheses. And when you get that, the measure of angle N is about 28 degrees. I think it was like 28.00 something, right? Yeah. And then what's the measure of angle O? That one's easy after this. Come on. Who calculate? Shane?
Around 81 like
What'd you get?
that. Around 81 like
So I got about 82. Yeah.
Yeah.
Did you use trig ratios for that? Or did you use the less signs for that?
No, I use I put in the irrational or the decimal form of my calculator.
Oh, gotcha. Okay. So guys, after this, it's just 180 minus 70 minus 28, which gives you about 82 degrees. You can, and I'm not saying you can't use the law of sines for that. You can. Okay? You absolutely can. But why? Right? I think we got enough stress in our lives, you know? All right. Let's take a look at the try it. Here's what we're going to do. I'm not going to go through this one, but I want you guys to try this one on your own. Okay, we'll read through it together. So suppose a pilot chose to fly north of a storm. How much farther is that route than the direct route? So they're talking about the route from here, Omaha to Chicago. Okay. So that's a total of 471 degrees. They want you to find this little Omaha right here. Okay. Call it Peyton Manning if you want. Omaha. Sorry. So find this, and they want to know like what the difference is. Okay. So I'll leave that to you guys, and we'll go over it in a minute. How we doing? Anybody still working on this? All right, what did we get? What was the difference? 19 miles. Yup. Does anybody need to see this? Okay, you do? Okay. All it takes is one. All right, so what I'm going to do here is, okay, I have 148. I'm going to cross to 147. So I'm going to have the sine of 148 degrees over 471. I'm going to set that equal to, now if this is what we're working with, I'm going to cross here. So this will be the sine of 15 degrees over, let's call it little o. I'm going to cross multiply. This leaves me with little o times the sine of 148 degrees equals 471 times the sine of 15 degrees. I'll divide both sides by sine of 148, which leaves me with O is equal to 471 times the sine of 15 degrees all over the sine of 148 degrees. Now remember, this goes in parentheses, and then calculate it out. You should get, what is it, 230? $230 miles? Yes? And then you're going to take, is it 230? Yeah. So this is going to be 230 plus 260 minus 471, which gives you 19 miles. Does that help, Satana? Thank you. All right, we good? Any questions before I shut everything down? Okay. Those who watch at home, have a great day. Are you still looking at it? Yeah. Okay, I'll give it a minute then. I'll just pause it.